We are now going to continue with problem 5 from this review. Problem 5, we're asked to find the domains of the functions. It looks like there are 4 different functions, A, B, C, and D. So problem 5 is basically what's the domain of these functions? So in other words, for A, the function is 3x to the 4th minus 2x squared plus 10x minus 5. Now, I explained in class the idea about domains. I will just try and do a very quick summary. I'm not going to take the time now to reteach this in detail. But if you recall, the domain of a function basically means what are all the possible values of x. And I said the way I think about domains is when I'm given a function, my assumption is, I say to myself, the starting point is, I'm going to assume the domain are all real numbers, which means x can be anything. Now that's going to be true unless I have 2 specific situations occur. And the 2 situations are, if you ever have a variable under the square root, then that's going to change my domain. Or the second situation is if I have variables in the denominator, or I have x in the denominator of a fraction. That's also going to affect my domain. So I look at my function, and I assume to start out with the domain is all real numbers, and then I ask myself, for my function, do I have any variables under the square root? Well, I don't even have any square roots here, so nope, I don't have that. Then I say, do I have any variables in the denominator? Well, once again, there are no fractions in this function. So basically, the domain for part A is all real numbers. Means x can be anything. All right, not too hard, right? Let's see what the rest of these problems entail. B, f of x equals square root of x minus 1. Once again, we want to figure out what is the domain. So once again, my starting point is I'm going to assume the domain is all real numbers, and then I see if I have either of my 2 special cases. Do I have any variables under the square root? I actually do. So now I have to take into account the effect of having the variable under the square root. So what's the deal? So once again, what I'm thinking of is the domain is what are the values of x? Or another way to think about it is what can x not be? Are there any values of x that are going to cause a problem? And that's what I have going on here. What's the issue? What's the thing we have to avoid in math with the square root? And we've already talked about this. For everything to be okay, we have to make sure what is under the square root is either a positive number or 0. In other words, we said this a few minutes ago, you can't end up with a negative number under the square root. We cannot take the square root of a negative number. So bottom line is, easiest way to think about this, you take whatever's under the square root and you say, you know what? I've got to make sure whatever's under the square root is greater than or equal to 0. That's in a sense what we're saying. So I'm going to write what I've been saying, write it actually as an inequality, and I'm going to solve this inequality, right? Get x by itself. If I add 1 to both sides, I end up with saying x has to be greater than or equal to 1. So what I'm saying is, because I've got x minus 1 under the square root, I know for everything to be okay, x has to be greater than or equal to 1. In other words, x could be 2, right? You plug in 2. 2 minus 1 is 1, that's okay. X can be 5. 5 minus 1 is 4, that's okay. What can x not be? Well, for instance, x cannot be 0. What happens if I plug in a 0 for x? I get 0 minus 1, square root of minus 1. I can't have that. I can't plug in like negative 10 for x. Negative 10 minus 1 is negative 11. I cannot take the square root of negative 11. So bottom line, hopefully it makes sense to you that, yeah, x is going to have to be greater than or equal to 1. And what I like to do, I like to go back when you first learned about inequalities. We used to use number lines to sort of graph those solutions. I still like to do this. So x greater than or equal to 1 means here's 1. Greater than or equal to is a bracket. So this, in a sense, is my domain. These are all the values that x can be for that function. Now, a lot of times we like to write the answer as an interval. So hopefully you all remember interval notation means what's the lowest value? It's a 1 with a bracket, which means to include 1. And this goes off to infinity, and of course infinity always has. Although I shouldn't say x. Instead, I should really say the domain is 1 with a bracket to infinity. And that should be the answer for part B. So let's see about C. So we were given 4 functions to find the domain of. Let's see what C is. C, the function is 5x over x squared minus 25. Once again, we're asked to determine the domain. All right, same procedure. I'm going to assume the domain is all real numbers, and then I look and see, do I have any variables under a square root? Nope, no square root here. Do I have any variables in the denominator? Yes, I do. So now we have to figure out what the impact of that is on the domain. So once again, we're really looking at, are there any values that x cannot be? Are there any numbers that we put in for x that's going to be a problem? What's the concern about having variables in the denominator? What is the thing that in the world of math we have to avoid in the denominator? And once again, we've already talked about it. This denominator, we have to make sure it's never equal to 0. So the question I have to ask myself is, what values of x, what number or numbers could I plug in for x that would cause this denominator to be 0? And whatever values of x would cause that, those cannot be part of the domain because we cannot allow that. Now in this case, actually what I need to do is factor here so I can very clearly see what values of x are going to cause me a problem. This is a difference of squares. Let me, just to save time, write it below. X squared minus 25 factors down into x plus 5 times x minus 5. Now let me make a point. Some of you might be thinking, well, what about the impact of this 5x in the numerator? We know what? This 5x in the numerator has no impact on the domain. I don't care about the numerator. I'm assuming the domain is all real numbers unless I have variable under the square root or in this case, variable in the denominator. Since I do have variable in the denominator, I've got to figure out how the domain is going to change, and it is going to change because of this denominator, but the numerator is not going to change the domain. It has no impact. I don't really care about the numerator. All I care about is this denominator. So now that I've factored, you notice we have these two parentheses multiplied. If either one of these parentheses equals 0, then the whole denominator is 0, and that's a problem. So let's figure out which values of x are going to cause the numerator to be 0. So if I look at this first parenthesis, what value of x would cause this first parenthesis to equal 0? Well, -5. If you plug in a -5 for x, -5 plus 5 is 0. 0 times this parenthesis, the whole denominator is 0, and then we got a problem. So I'm going to say I know x cannot equal -5. If I look at the second parenthesis, what value of x would cause the second parenthesis to be 0? In this case, 5. So there's another value of x that I know I cannot have. So because of the denominator, I know that x cannot equal -5 or 5. So my original domain was going to be all real, but now I've actually found two values of x that are not in the domain, that I cannot leave in the domain. So in this case, just to keep it pretty simple, what you can do is you can say the domain is now going to be all real numbers except if x is equal to plus or minus 5. So this is saying the domain is all numbers except plus or minus 5. X cannot be plus or minus 5. And that would be your answer. And that's a perfectly fine way to write it. All right, the last domain problem. D. F of x equals square root of x minus 1 over x squared minus 5x. Once again, we want to know the domain. All right, same thought process. I'm going to assume the domain is all real numbers. Then I'm going to look for my two special situations. First of all, do I have the variable under the square root? Turns out I do. And just to keep checking, do I have any variables in the denominator? I have that. So here's a case where both the situations I have to look for, they're both occurring in this function. So somehow I have to figure out the domain, and I have to include the impact of the variable under the square root, and also the impact of having a variable in the denominator. So how would we go about including both of those in order to find the domain? Well, what I do is I will take a look at the impact of the square root first. So like we talked about before, you take whatever's under the square root and you say that has to be greater than or equal to 0, and I solve for x, and I'm going to do my number line again. X greater than or equal to 1. So here's what I have. The impact of the square root is this. My new domain is now all values of x greater than or equal to 1. But now I need to look at what's the impact of having variables in the denominator. Now this actually factors again. There's a GCF. Let me try and squeeze it in here just to save time. If I factor out an x, I have x times x minus 5 and I have to ask myself, okay, what values of x, what numbers would I plug in for x that would cause the denominator to be 0? This first x here, obviously, I cannot let x equal 0 because 0 times a parenthesis is 0 and the whole denominator is 0. So x cannot equal 0. And now if I look in the parentheses, what value of x would cause the parentheses to be 0? 5. So in this case, there are now two numbers for x, two values of x, which I can't have. X cannot equal 0 or 5. So taking this information, and let's go ahead and sort of transfer this information to this number line to sort of get a feel for what's going on. So first of all, I want to say that x cannot be 0. 0 is right here. But you notice on my number line, 0 is not currently in the domain. The effect of the square root has eliminated all the numbers less than 1. So right now, this 0, I'm fine. It's taken care of. It's not currently in the domain, because the domain currently says x has to be greater than or equal to 1. Now let's see about 5. Well, if you look on the number line, 5 is maybe right here. Now 5 is definitely currently in the domain, which means this domain came about as a result of the square root. So if it's up to the square root part of the function, 5 is perfectly fine with the square root. It's not going to cause a problem. However, 5 is going to cause a problem with the denominator. So we cannot include 5 as part of the domain. So in a sense, what we have is from the square root, the domain is everything greater than or equal to 1. From the denominator, basically, we have to say 5 is not included. So how do we combine these two together? So what you do is, I'm going to start here at 1, and I'm going to go to 5, and I'm actually going to stop. So I put a parenthesis there. The parenthesis says do not include 5. But then I realize if I just sort of skip or jump over 5, then the rest of these numbers should be in my domain. At the top, the numerator and the denominator are both fine. So what I do is I sort of do a back-to-back parentheses and then keep on going. So this is the way to show that my domain starts and includes 1, it goes to 5, it jumps over or skips 5, and then it goes on to infinity. So the domain is really all values of x greater or equal to 1 except for 5. Now the way we write that with intervals, we write it as two separate intervals. I write this interval first. I'm starting at 1 and I'm going to 5, but 5 has a parenthesis, which means you don't include 5. And then I'm going to union, which means I'm going to combine these two intervals together, and now this interval starts at 5 with a parenthesis and goes on to infinity. So that's the domain for part D. All right, now 6, 7, and 8 all have to do with reviewing, remembering about calculating slopes of straight lines. So let's just go ahead and see if we can maybe get these done on this video, then we'll start a new video. So 6 says to determine the slope of the line that goes through the following 2 points. So we have a line, and I'm given 2 points, -1, -1. So once again, -1 is x, -1 is y, and the second point is, 1, 5. So they're asking what is the slope of the line that goes through these 2 points. And of course, hope you remember, slope is always symbolized by the letter M. Now on the test, I will give you this next equation. We have this thing called the slope equation, which is what we use to calculate the slope of a line that goes through 2 points. And it's y2 minus y1 over x2 minus x1, where x1, y1 are your first point, and x2, y2 are your second point. So I've got 2 points here. Doesn't really matter which point I call my first or my second point. It doesn't matter. I'll just go ahead and call this my second point and this my first point. So you simply say y of my second point, which is 5, minus y of my first point, which is negative 1. Be careful, it's y2 minus y1. So 5 minus, and then y1 is negative 1, over x of my second point, which is 1, minus x of my first point, which once again is minus 1. So really, we're going to see in a little bit when we look at some graphs that this is a mathematical way of saying rise over run. Or how does the rise, the up and down, the value of y change divided by the run, or how does x change? So mathematically, 5 subtract a negative 1, that's like 5 plus 1, so that's 6. 1 minus a negative 1, it's like 1 plus 1, that's 2. Looks like the slope of the line that goes through those points is 3. Now problem 7, it's once again dealing with a straight line. It says determine the equation of the line that has a slope of negative 3. So we want equation of the line, that's what we're looking for. And our line has a slope of negative 3, and they give us a point on the line, 2, 2. So they've given us a point on our line, and they've given us a slope of the line, and they want to know the equation. And normally when you give the equation of a line, it's normally y equals whatever. Now here's another formula or equation that you'll be given for the test, and it's called the point slope equation, and it's called that because anytime if you have a straight line and you know a point on the line and you know the slope of the line, then you can calculate the equation of the line. So it's called the point slope equation. And the point slope equation is y minus y1 equals mx minus x1. So m is your slope, x1, y1 would be the point. So you plug those in, and then it's very easy to calculate the equation of the line. So y minus y of my point, which is 2, equals the slope, which is minus 3, times x minus the x of my point, which is 2. Now, like I said, normally when you give the equation of a line, you want to get the y by itself. So I'm going to multiply out these parentheses, and I'm also going to add positive 2 to both sides in order to get the y by itself. So when I multiply out the parentheses, you get minus 3x plus 6, right? Minus 3 times x, minus 3 times minus 2. Now if I add 2 to both sides, end up with y equals negative 3x plus 8, and that is the equation of a straight line. All right, number 8 actually has us looking at a couple lines on a graph. So let me actually pop this up here so we can do this one. Let me try and zoom in a little bit. Well, first of all, let's read the instructions. Number 8, the graph up. Oh yeah, it does. Does it have 4 lines? Yes, it does. It's not always easy to tell. So here's the origin is right here, right? Because you see zeros here. So here's the x-axis. Here's the y-axis. So here are the axes. Now these lines aren't labeled. I'll go and label them. You see this line right here, this vertical line that looks like it goes through x equals 1? I'm going to call that line 1. It's very hard to see, but there's actually a horizontal line right here. I'll call that line 2. And then there are two sort of slanted diagonal lines. I'll call this line 3 and this line 4. So it's maybe hard to tell initially from looking at this, but there are 4 lines on there. So they say for each line, find the slope of the line and then the equation. Which actually, in order to find the equation of the line, you really need to find the slope. So now let's look. Lines 1 and 2, there's really no math to do because these are special cases. Hopefully you remember, look at line 1. So for line 1, a perfectly vertical, straight up and down line, what's the slope of that, you recall? It's actually undefined. When we have a graph, the way we like to calculate the slope is you just choose 2 points, and then you move from the first point to the second point in a stair-step type fashion, and you calculate rise over run. Let me do it here. So we're going to calculate the slope of these lines by looking at the rise over the run. So for instance, if I just pick any 2 points, doesn't matter which point you choose on a line, the slope's always going to be the same. If I choose these 2 points, the rise, so I'm going from 2 to 3, the rise would be 1, but what's the run? The run is 0, so 1 over 0 is undefined. That's why the slope of a vertical line is always undefined. Let me do line 2 right here. So line 2 now is this horizontal line. If you think about, we could just choose 2 points over here. Rise over run. Going from this point to this point, what's the rise? There is no rise. The rise is how much does it change up and down? It doesn't change at all, so it's 0, and the run is like 2. So 0 over 2 is actually 0. So the slope of that horizontal line is 0. Now the equations for line 1, whenever you have a vertical line, the equation of the line is simply whatever the value of x is for that line. This line, every point on this line, x is going to be 1. So a horizontal line, we simply say the equation for that line is x equals 1. For or I may have said horizontal, I meant vertical, right? Vertical line, the equation is x equals 1. For a horizontal line, you just figure out the value of y for this line. Looks like it's 3. And that's the equation for that line. So those are the special cases, the vertical and horizontal lines. Now the third and fourth are just sort of slanted or diagonal lines. So they're going to have, when we find the equation of the line, they're going to have both an x and a y in it. Anytime you have a slanted or diagonal line, when you find the equation, you're always going to have both an x and a y. Now the way I'm going to figure out, first of all, we're going to figure out the slope by choosing 2 points and stepping it off to get the slope. And then the way I'm going to get the equation of the line is to use that point slope equation. So let's just do these. We'll do 3 first. So what I have to do, I have to try and find 2 points on this graph that's very clear that I can determine what's going on. This thing has a mind of its own. Let me just make it very clear here. So I'm going to choose this point right here. It looks like x is 0 and y is 4. I'm on actually the y-axis here. And let's go down to this point here. Hopefully you can see that at this point x is 2 and y is 3. So hopefully you can see that. So let me move out so we can see what I'm doing now. So for line 3, rise, I'm going to go from here to here. So the rise is up and down. I actually go down 1. So that means the rise is actually -1. And then the run is how far do I move horizontally. I actually move 2. So the slope of line 3 is actually -1/2. So we're over here. Now if I want to find the equation of that line, I'm going to use the point slope. So I've got my, once again, the point slope, which you'll be given on the test, is this equation right here. Here's your slope. x1, y1 is your point. So let's just choose a point on this line. How about I choose this point here? This point here is 0, 4. That should be pretty simple. So y minus the y of my point, which is 4, equals my slope times x minus the x of this point, which is 0. So if I multiply out the parentheses and get the y by itself, so I'll add 4 to both sides. Hopefully you can see it's not too hard to do. And that would be the equation of line 3. Now let's do the same thing for line 4. First step is to determine the slope. So let's see if we can see. How about we'll do it down here. It's not quite as messy. So if I go from here to here, so down here I'm at -2. Up here I'm at x is 1. So rise over run, here to here is 2. So a rise of 2. And then a run horizontally, I move 1. So the slope should be 2 over 1. So we just say it's 2. And now let's just choose this point on our line to find our equation. That point there is going to be 1, 0. So the point slope equation, y minus the y of my point, which is 0, equals the slope times x minus the x of my point, which is 1. So if I multiply out the parentheses, the equation of that line would be 2x minus 1. Oops, 2 times 2. I checked the key. The key was correct. I was wrong. Matter of fact, let me check the key for both of these. Make sure I didn't mess up. Y equals -1/2 x plus 4, and y equals 2x minus 2. All right, so those are the problems, sort of reviewing straight lines, slope, intercepts, equations, etc. All right, so let me stop this video. In the next video, we will look at another function on a graph.